Hello friends, in this video I'll show you how to implement linear regression model in Python from scratch. Before dive into code, we'll see some basic math behind this algorithm. I hope you know some basic linear algebra and Python coding. For now, we see a high level view of a linear regression maths behind this algorithm, and after that dive into coding part. This is our basic line equation, y equal to b plus mx, where b is the intercept and m is the slope of line. I represent this equation by h of x equal to theta 0 plus theta 1x. To start this algorithm, we need to assume theta 0 and theta 1 randomly. Any point come in your mind, you can choose. Here theta 0 is 50 and theta 1 is 0.06. Now we need to find error. Error is the difference between our actual output and our predicted line. This is our actual output and this one is our predicted line. We represent the error with h of x minus y, where y is our actual output and h of x is a predicted hypothesis. Our goal is to minimize the error between our actual output and our predicted line. When error is minimum, then this line shifts towards our actual outputs. So the question is how we can minimize this error. By the way, this is a error matrix. The difference between each point of our actual output and our regression line. To understand how we can minimize this error, we need to understand a cost function. This is our cost function and this one is a error part. We squared up all the errors in matrix and summed up together and divide it with total number of observations. This equation will return a cost value. Suppose it returns a value like 10,000. After minimizing the cost function, it may be 1,000, 2,000, 3,000. We need to minimize the value as much as can possible. To minimize the error, we need to find derivative of cost function. And multiply it with alpha and subtract it with initial values of theta. These are our initial values of theta. This is our derivative of cost function. With respect to theta 0 and theta 1. After that, we put this value in this equation. So these are two final equations. So I think now we need to jump in coding part. I am using two libraries, pandas as PD for reading CSV, matplotlib as PLT for plotting graph. First we need to read CSV, pd.read CSV as matrix. This is our CSV file. X is input variable and y is output. I use 0.0001 as learning rate, intercept 0, slope 0. These are initial values of intercept and slope. Iteration 1000, x as input variable, y as output variable. Now I will show you initial cost when intercept and slope is 0. I am passing x, y, intercept and slope to cost function. This is our cost function. If you remember, this is same equation as we had studied in our previous slides. This is our error, y minus hypothesis, and scare up all the errors and summed up. After I divide it with total number of observations. So now we'll check what is our initial cost. This is our initial cost. I am using plt.scatter to plot data on graph and plt.plot to plot regression line on graph when slope and intercept is 0. This is how our data and our line looks like. At this stage, cost is maximum. So we need to reduce cost by using gradient descent. I am passing x, y, intercept, slope, learning rate and number of iterations. So this is our main gradient descent function. If you remember, these two equations are same as we studied at last slide. These two equations, I am using these two equations to minimize cost. And then multiply with learning rate and subtract it with theta 0 and theta 1. Theta 0, theta 1. After reducing cost, we'll see what happened when I run this code. So at this stage our cost is minimum. This is our final cost. I hope you got all the points. In next video I'll show you how logistic regression work. So thank